Hi, this video is about border detection. We already did one that was called border detection 1. This one is called border detection 2 and has to do with something very similar but a tiny bit different. It's going to be very easy if you did the first one. The first one had to do with border detection where the drawing looked like this. It was about elements that were smaller than the container. This one is going to be about elements that are larger than the container. In the last example, we dealt with small moving squares we wanted to keep inside a box. In this example, we're having a large element we want to keep covering the container. For me, it's totally impossible to figure out any algorithm without looking at the drawing. So here we go, back to the drawing. I'm going to keep this explanation one-dimensional on the horizontal level, because once we've got that, it's very easy to make the vertical part. The container, the yellow one, left is 0, width 100, nice and round so that it makes it easier for us to guess how the numbers are working together. The element, 1.5 times bigger than the container, left is 0 and width is 150. So let's try to look at the left side. What we want to avoid if the element is moving towards right is this. We don't want to show any stage. So if the element's x is larger than the container's x, then we want to reposition it here and stay here. So the code may look like this. Sorry, my tab isn't working. If element x is greater than container x, then the element x will be reset to the container x. This should take care of this border, the left one. Now let's try to have a look at the right side border. If we're moving the element towards the left, what we're trying to avoid is this. So we want to reposition it here if that happens. And where is that? We can actually read that the left position should be around -50. So how do we know that? Well, we know that this is 100. We know that the element has to be relative to the container. So if we count down 150 from 100, it will be -50. We really need a formula for this one. So how can we make our numbers equal -50? We could subtract 100 from 150. That will make 50 and put a minus in front of it. So minus element width minus container width. That will make -50 and will fit any element width on this position. Could also be even simpler. It could be 100 minus 150. So the container's width minus the element's own width. Container's width minus element width. This is even simpler. And remember, it's only when the element is smaller than that value that we want to reposition it. So if I could paste in the if sentence, if element x is smaller than this formula, then we want element x to be reset to this new value, because this allows it to still cover the container. Of course, it implies that all these variables are declared and contain some real values for the case. Let's get rid of this one. If we don't have any vertical movement in this composition, that is on the y-axis, it can still be a perfect horizontal composition with a big background moving from its extreme right position to its extreme left position, and that sounds very political. If we take the example I showed you before, it could be something like this. I'm just pretending that there's no movement up and down by holding the mouse as horizontal as I can. Actually, there's another variation further down. It looks like this. You see? Moving from the left to the right, but being larger than the screen. But if we do have some vertical movement, we still need two if sentences if we want to do some border detection on it. We have two scenarios. We have the elements y that's on its way under the top position, like this. This we want to avoid, and we want to reposition it on the top position. Or we can have the other way round, the elements y that's coming above the button position, like this, so that we want to reposition it on the button position. In either case, we can duplicate the code we already made and exchange the x's with the y and the width with an h for the height, because both directions work using the same principle. Of course, you are now dying to explore the possibilities of doing a vertical only movement case. A very tall background, I don't know, a tree, could be a necktie or something, and find all the possible exciting use cases for it. So I'll leave you to it and have fun.